The subject of this video is this thing called standard form, and adding on to that, how can we use standard form to find the vertex of our parabola? All of this is going to continue on with our research of these beautiful parabolas or quadratic graphs, and in theory, you've already taken a look at this form called the vertex form, and it's just a different form that will give way to the graphs that you looked at. And on the other side of that note sheet, if you have that note sheet, is the standard form. In standard form, you always have your exponents go in descending order. We did that in previous units. This would be called standard form because this is the biggest exponent, the next biggest exponent, and there's no exponent at all. When we do this in practice, the A, B, and the C are going to take on values. This clunky formula over here is going to help you to find the vertex of your graph, because if there's one star of the show on these, it very well could be the vertex. So let's get at it and do an example. In this example that you see right here, you can find out easily that it's in standard form, biggest exponent, next biggest exponent, no exponent. So this would act as the A, the 8 would act as the B, and the -5 would act as the C. So it's worth your time to write those down because they're also going to be in your future chapters. When I look at the A, it's the same thing that we learned in the previous form. If the A is positive, which it is, the function or the graph is opening upwards. And if the A is bigger than 1, we have a graph that is more narrow than the parent graph. But now let's take a look at how we can take this graph and find the vertex. The formula to find the vertex looks pretty clunky. To find the x value of the vertex, we do -b over 2a, and when we finally get an x value out of that, we're going to plug it into the equation and we'll get out a y value. Once we have this x and the y value, we now then know where exactly the vertex of your parabola is on the graph, on the coordinate grid. So in the example we're working with, I go through baby steps. I know my b and my a by looking at this original equation. So now I take the formula -b over 2a, -b over 2a. My b was 8, my a was 2. That negative comes with the formula. So now through baby steps, 2 times 2 is 4, -8 divided by 4 is -2. I now know the x-coordinate of my vertex. But to really know exactly where my vertex is going to be on the coordinate grid, I need a y value. So we do the same thing we've done for many, many times in the math world. You take your x value, you plug it in for x, and you do the math, and you'll get out a y value. And there you see it down here. My x value of -2 gets put where there was an x squared. That x is -2. And now I just gradually take that and through baby steps resolve it down into a number, 2, -13. This tells me if I were to graph this parabola, I don't even know what the heck it looks like at this point other than it opens upward and it's a little narrow. The vertex would be way down here, wherever -13 is. So way down there at the bottom of the screen, -2, -13 is the vertex of my parabola, and I know it opens upward, so it's going to do something like that. One final example, and it might be smart for you to work this by yourself. Here's my original equation, and before you get going on your own, I would say, hey, that thing's not in standard form, so you're going to want to rearrange it. This term needed to be in front, and this term needed to be second, so that we go greatest exponent, next greatest exponent, no exponent. Now we know our A, B, and our C. This is telling us the parabola is opening downward because A is negative, and it's more narrow than the parent graph. These numbers are going to be quite a bit more messy, but you could pause the video and see if you can plug it into the formula, negative b over 2a, and go ahead and find out what the vertex of this graph is. All my work is now going to show up after this, so if you were going to do that on your own, pause it and give it a shot. You can compare it to my work. Okay, here's my work. Since I already have my A, B, and C, and the formula says negative b over 2a for the plug-in, that's a negative because of that, but then a negative 10 because b is negative 10. A negative negative 10 is positive 10. The denominator is 2a, 2 times a, because I see my a. So now 10 divided by negative 8 gives me this x-coordinate. Ooh, it's a decimal. Decimals are okay. Now that I have my x-coordinate, I have to plug it in to the equation to get out my y-coordinate. So you see that work right below. Negative 4x squared, negative 4x squared, minus 10x plus 15. And now I just have to carefully go through calculator work. I must square the negative 1.25 before I multiply, because beautiful Princess PEMDAS wants exponents done before multiplying. And gradually this turns into a nice tidy number. So now I know that the vertex of that graph is at that location on the coordinate grid, and my graph is going to open upward. Oh, sorry, it's going to open downward because that's negative, and it's going to be more narrow because the 4 is bigger than 1.